Go. Okay, today you're going to be learning about kinematics. To do this, you're going to want to have your formula chart with you. When you're in class, our formula charts are going to be this blue formula chart. Okay, and you'll have one in class, but for your own, you're going to want to keep it with you. You're also going to want to make sure you're taking notes as you go, and you can pause the video if you need to continue writing. I highly recommend that. If you're not doing that, it's going to be a problem for you. Okay, so kinematics, we're starting to talk about motion in two direction, and these are the three equations. I say three, you see the three in black? That's because those are the ones that are actually on your formula chart. If you look at your formula chart, the first three equations in order are these three equations, okay? They look a little bit like gibberish now, okay, but as you start using them, you'll see that it's not that bad. Okay, so breaking some of these down, when you see a V with a 0, that tells you that this is the initial velocity. We call that V naught, okay? When you see a Vx or a V in another letter, that's usually the final velocity. That's just the velocity of object x. They've just labeled it with an x. Okay, same thing, when you see ax, that's just the acceleration of object x. Okay, and then t is time. Okay, if you go down, this is all from the first formula right here. If you go down to the next one, you'll see x and x naught. That's the initial position and then the final position. Okay, so they start to make sense once you see them and once you use them, so we're going to keep going. If you see this red formula, you might want to pause and write this one down. This is a formula that's super useful to you that is not on your formula chart, and you will have to memorize it. Notice it's the only formula that doesn't have acceleration in it. This one has acceleration, acceleration, acceleration. So if you get a problem and it doesn't have acceleration in it and you don't want to have to derive a formula, you can memorize this one. I highly recommend it. Okay? So going through, remember as we're working these problems, direction and 0 is up to you. It's best practice to make 0 your starting position and your starting velocity if they don't give you one, okay? But your direction could be positive that way or positive that way depending on the question or your preference, okay? So pay attention as you go and make sure you're doing everything in the direction you assign positive, positive, and everything in the direction you assign negative as negative, okay? Because there's multiple quantities that we're dealing with now. So here's our first example. If you notice up here, I'm telling you we're going to work this problem with negative in the right direction and positive in the left direction. So here's our example. A car is traveling 40 meters per second, that's important to us, and has a constant acceleration of negative, okay, 4.75 meters per second squared for 6 seconds. How fast is this car traveling? So your first step when working this problem is to figure out what the problem gave me. Okay, my car is traveling at 40 meters per second. That is my initial velocity to start, is 40 meters per second. Okay, it has an acceleration of a negative 4.75 meters per second squared. This tells me that it's accelerating to the right because I'm doing right negative. Okay, my car is moving to the left because this number is positive. And my time is 6 seconds. Okay. The last thing I need is what am I looking for? How fast is the car traveling at the end? I want my final velocity is I don't know. Okay? So once I have what I have and what I need, I can look at my formula chart and decide what's the best formula to use. If you have your formula chart, the best one to use in this case is the very first one because it has everything I need and everything I have. So it's Vx is equal to V naught plus AT. Okay, now I have my formula, I just plug my numbers in, I'm looking for Vx, my initial velocity is 40, my acceleration is a negative 4.75, and my time is 6, and this becomes an easy equation to solve. Okay, you just stick it into your calculator appropriately, following order of operations, and you should end up with 11.5 meters per second. Okay, and if I look at my answer, I should be able to tell if this is traveling to the left or to the right because it's positive. Whatever, this car is traveling to the left when it's over. It has slowed down, but it's still going left. Okay, so let's go on to our next example. Here's our next example. Let me erase. Going through, if you notice up here, I've changed directions on you. I am now working this problem with right as my positive direction. Okay, so a car traveling with an initial velocity of 6 to the right accelerates at 2 meters per second for 6 seconds. So if we look at this, let's write down what we have and what we need. We have our initial velocity of 6 meters per second to the right, so it stays positive, because right is positive. It's accelerating. This number is positive, so I'm going to assume it's accelerating to the right. Okay, and it's doing this for 6 seconds, and I want to know the final velocity. Okay, so I have all the same variables as before. I'm going to look through my formula chart and find the one that I need. It happens to be the same one this time, and I'm going to say Vx is equal to V naught plus AT, and we're going to plug all of our numbers in. Acceleration is 2, time is 6, and then we're going to solve the equation. Okay, and you may use a calculator any day in my class. Okay, so we have this final velocity. It's still positive just like the last answer, but because my direction is now positive to the right, this car is traveling right even though they were both positive. So each question is independent from the other question. Okay, let's go through and do 2 more examples real quick. Okay, going through to the next kinematic problem. Okay, notice we're doing the exact same problem we did before, except I've switched my direction on you. Okay, I'm doing right negative, okay, and left positive. A car traveling with an initial velocity of 6 meters per second to the right. So my V naught is still 6 meters per second to the right, but this time I have to make sure that I give it a negative sign, because right is negative. Okay, acceleration, it's accelerating at a negative 2 meters per second, so that means it's accelerating to the right this time. Okay, you can think back to our previous lectures, what does that tell you if this and this match? Okay, it should tell you that my car's speeding up, so it should have a bigger velocity when we get to the end of this problem. Okay, so time is still 6 seconds, and my Vx is still what I'm looking for. So same equation, Vx is equal to V naught plus AT. I plug in my answers. This is still what I'm looking for. Negative 6 plus a negative 2 times 6. Okay? When you solve this problem in the calculator, you're going to end up with a negative 18 meters per second. Okay, and I can check what I know. I said it should be speeding up. It was going 6 and now it's going 18. And I know that it's still traveling in the right direction because right is negative. Okay? We're going to work one more problem real quick. And then you should have enough to get you started. Okay, so kinematic example number 3. A car traveling with an initial velocity of 6 meters per second accelerates for 5 seconds and travels a distance of 65 meters. What is the car's final velocity? Okay, so what do we have? We have initial velocity here of 6 meters per second. It says it accelerates, but it doesn't tell you for what the amount is. So we don't have this quantity, but we do know that t is 5 seconds and distance is 65 meters. And we are looking for final velocity. If you stop and look at your formula chart, none of these formulas will help you. They all require acceleration. Okay, this is what we were talking about. You need to memorize this red formula from the beginning. Okay, and it will help you. It has everything you want and everything you need. Okay, so we have delta x, it is 65. We have Vx, Vx is what we're looking for. Okay, we have V naught, it's 6, and we have the time, it's 5. Okay, so we go through and algebraically solve this. The first thing I'm going to do is I'm going to cancel this out. I'm going to say this is really 2 times 65, and this will go away, is equal to Vx plus 6 times 5. Okay, we're going to divide both sides by 5 to get rid of this. And then we're going to say 2 times 65 over 5 plus 6, or minus 6 will get me Vx. Okay, if I subtract 6 here, this goes away, and I end up with minus 6 on this side, and that will solve my equation for me. And you should get an answer of 20 meters per second. Okay, so looking at this, it gave me no direction, so I can say that it's right or left as long as I assign positive to right or left. You have to pick. Okay, so when you're working in my class or in Miss Brown's class and you want to receive full credit on an answer on a question, you have to do all 5 of these things. You have to write the variables like I did. If I have to do it, you have to do it. You have to write the formula, you have to plug and chug and show your work. Okay, put an answer in units. Make sure that you box in the answer with the units so it's easy to find for Miss Brown and myself. Okay, thank you so much.